Welcome back, everybody. So this is the second part of the lesson on the quadratic formula, which we derived in the last video. And let me just remind you what that is. So up here we had a quadratic equation in this form. Then the solution is given by this expression. That's minus b plus or minus the square root of b squared minus 4ac divided by 2a. All right. Now, in these examples, we just have to think through a few things before we apply it. Here, they're asking you to find the x-intercept of this graph given by y equals 2x squared minus 5x plus 2. Well, because this is a quadratic expression, we know that the graph is going to be a parabola. And in fact, it's going to be a parabola that opens up. But the x-intercepts are going to be where where y is 0. So basically, you want remember when we find the x-intercept, we set y equals 0. Okay. So if we use the quadratic formula, in this case, a is 2, b is negative 5, and c is 2. So, according to this, we would take x would be minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. Well, let me just simplify this. So this is going to be plus 5 plus or minus the square root, and you can check this is 25 minus 16. So 25 minus 16, I think hopefully it's 9, right? And then 2 times 2 is 4. Okay, and we know that the square root of 9 is 3. So this is going to be 5 plus or minus 3 over 4. If you have 5 plus 3, you get 8 over 4, which is 2. If it's 5 minus 3, you have positive 2 over 4. So this is 1/2, right? So these are the two x values that cause this to be 0. So the x-intercept would be 2, 0, and 1/2, 0. All right. Now let's just see what the question is. Does this intersect the line at y equals negative 6? Okay. So now we're just, this is kind of the same thing, similar to what we did before, except instead of we want y to be negative 6 instead of 0. So we set negative 6 equals 2x squared minus 5x plus 2. And we can add 6 to both sides, and we get 0 equals 2x squared minus 5x plus 8. All right. Now, if this has a solution, then the answer is yes. There'll be an intersection, and if it doesn't have a solution, then the answer will be no, it doesn't. So a is 2, b is negative 5, c is 8. And let's just go ahead and we'll see that the answer will be, if there is a solution, x would be negative 5 plus or minus negative 5 squared over 4 times 2 times 8 over 2 times 2. And this becomes 5 plus or minus. Now, what will this be? This is 25 minus 4 times 2 is 8. So that will be 4 times 2 times 8 is 8 times 8. That's 64. So this will be 25 minus 64 over 4. And this is going to be 5 plus or minus the square root of 25 minus 64. We know that this is, well, we already know that something is wrong here. This will be a negative number. But it looks like this will be 39, I think. negative 39 over 4. Okay, and we did that right, and I think we did. So the problem is that this is not real. And because this doesn't have a solution, so the answer is no. Okay. And in fact, we could have just done this just by looking at the discriminant. If we just wanted to find out, does the solution exist or not, we could just go ahead and look at the discriminant and see that it's negative. All right. Keeping in that mode, say if we just want to find the number of solutions to the equation, it's really just a matter of looking at the discriminant. And seeing if it's positive, negative, or 0. Now, if we want to go ahead and find solutions, you can do that, but here they're just asking for the number of solutions. So it'll either be 0, 1, or 2. For this first example, we need to put everything on one side, though. So we'd have x squared minus 5x plus 4 equals 0. And so in this case, A is 1, B is negative 5, C is 4, and the discriminant would be negative 5 squared minus 4 times 1 times 4. That's 25 minus 16. Once again, that's 9, so that's positive. So there are actually 2 solutions. Okay. In this example, we have 3x squared equals 12x minus 12. We'll put all the solutions on one side again, and this will be 3x squared minus 12x plus 12 equals 0. So A would be 3, B would be negative 12, and C is positive 12. By the way, you could look at this. You could divide everything by 3 first, but you don't have to. But B is negative 12, so negative 12 squared minus 4 times 3 times 12. And you can check that this is 144, this is 144. So this actually is 0 once you compute it out. And so because it's 0, that means we have one solution. In this last equation, we can do the same thing. Notice everything is on one side now, so we don't have to do anything. We can just say A is 2, B is 1, C is 1. And so B squared minus 4AC is going to be negative 7. That's negative, and so there is 0 solutions here. Okay. You get that just from looking at the discriminant. Okay. Last example. Through physics, we can find that if a stone is tossed into the air, its height at time t. Ooh, and this, I should know there's no apostrophe here, but whatever. Its height at time t is given by h of t equals negative 16t squared plus 69t plus 4. Okay. Now I should say that this is only going to make sense for positive values of t, right? Because we're taking a t equals 0 as the time it's tossed. So the question is, when is the height equal to 15 feet? So we want to set h of t equal to 15. And then, so that's negative 16t squared plus 69t plus 4 equals 15. And again, we want to solve this for t. It doesn't matter if, well, first we'll subtract 15 from both sides. And we'll get negative 16t squared plus 69t minus 11 equals 0. So this is now this is a quadratic equation. You know, we just have t instead of x, but everything else stays as before. A is going to be negative 16, B is 69, and C is negative 11. Okay, so t then will be minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right. Okay, if you go ahead and compute this, this is negative 69 plus or minus the square root of 4,057 over negative 32. And you'll see that, okay, the top, the bottom is going to, the denominator is negative, but that's okay. The numerator is going to be negative in both cases as well. And what this turns out to be is you get two solutions. If you plug this in your calculator, you get 0.017 seconds and 4.15 seconds. And this kind of makes sense because if you're tossing it up, okay, it's going to be exactly 15 feet twice. Okay, one going up, and then one coming down. Okay. All right. So then the second part is, when does the stone hit the ground? Okay. Well, in this case, if it hits the ground, the height is 0. So we do this again with 0. Okay, there. Now we just have a 0 on this side, so we can just go ahead and see that A is negative 16, B is 69, and C is 4 this time. And then T is going to be negative 69 plus or minus the square root of 69 squared minus 4 times negative 16 times 4 all over 2 times negative 16. This is negative 69 plus or minus, when you plug it in your calculator, this is 5,017 all over negative 32. And you'll get two solutions. One will be negative 0.06 seconds, and the other is 4.37 seconds. And the only thing we really care about is this last one. This negative solution, that doesn't mean anything, right? Because we know that when we toss the stone up, it's only going to be hit the ground once, right? So we just want the time where t is bigger than 0 in this case for this to make sense. And it really doesn't make sense to say, 0.06 seconds before it was tossed, the stone was on the ground. That's not true, really. So, I mean, when we see an equation like this, we're really assuming that t is greater than or equal to 0. And obviously, also, after it hits the ground, it doesn't continue sinking into the ground, right? So this equation just models it for a very short amount of time, from 0 to 4.37 seconds. Okay. So thank you for following with all this. Go ahead and do the homework, get some practice, and I'll see you next time.